हरि करना।
So now let's put all of the terminology and the parameters that we have learned in practice. Let's take one example and let's do it. So suppose a researcher wants to test. So test, let me put example. He wants to test the hypothesis. That hypothesis is equals to new teaching method improves students' performance in math. Okay, so for him the null hypothesis is equals to there is no difference in performance between the new teaching method and the traditional method. Okay, traditional method, and alternate hypothesis is equal to there is a difference. Okay, we got our alternate and null hypothesis with us. Now the researcher randomly selects 100 students. So researcher randomly selects 100 students and randomly assigns them to either the new or traditional teaching method. So now once this is done, the mean math test score for the new teaching method, the mean math test score for the new teaching method group is 85 with a standard deviation SD is equals to 10. This is with the new teaching method. And second, the mean test score is 80 and SD standard deviation is 8 for using old teaching method. Okay, so now the researcher performs a 2-sample t-test with a significance level of 0.05. So step 2. So now researcher performs a 2-sample t-test with a significance level alpha. So with a significance level that I am taking alpha is equals to, as usual, we'll take 0.05 or 5%. Then the t-test results in a p-value of 0.2. So then the t-test value in p value is equals to 0.02. So which is obviously less than, so p value is lesser than the significance level, that's alpha, which is equals to 0.05. So this means that the observed difference in mean test scores between the two groups is statistically significant. Therefore, the researcher can reject null hypothesis and reject null hypothesis and conclude step 6 and conclude that new teaching method improves students' performance in math. So, however, the researcher should also consider the possibility of type 1 and type 2 errors. A type 1 error would occur if the researcher rejects the null hypothesis when it is actually true, meaning that they conclude that there is a difference in performance when there is not. So now the probability of type 1 error in our case is 0.05. So now step 7, we need to look into the possibilities of type 1 and type 2 errors. So obviously we have rejected the null hypothesis, correct? We are saying new teaching method improves. So we have rejected the null hypothesis. Now what's the possibility of type 1 error? In this case, type 1 error probability is equals to 0.05. So type 2 error would occur if the researcher fails to reject the null hypothesis when it is actually false, meaning that they conclude that there is no difference in performance when there is. So the probability of type 2 error depends on several factors such as sample size and effect size and alpha level. But however, here we have rejected the null hypothesis. We can have the type 1 error, but when it comes to the type 2 error, so we did not confirm it. If we confirm the if we confirm the null hypothesis, then the possibility of getting type 2 error. But here we did not confirm the null hypothesis, we have rejected that, then I will have a possibility of type 1 error, that is a 0.05. So to reduce the risk of type 1 and type 2 errors, the researcher could increase the sample size, use a different statistical test, or adjust. So here we have used t-statistic. You can use different types of statistics or statistical test. So the final one, to reduce the risk of type 1 and type 2 errors, what should we should do? The researcher should increase the first one, increase the sample size, to use a different statistical test, 3, adjust the alpha level, So ultimately the researcher should carefully consider the trade-offs between type 1 and type 2 errors. and select the appropriate statistical methods and significance levels to make robust and accurate conclusions from that. Okay, if you want to write, no, execute and see a code on this, let me check. Let me copy this code and let's write it down, new code completely. Okay, so let's import the required things for same example, whatever example that we have taken for the same example. So import numpy, then scipy stats. Okay, then t-test, the t-test is the one which we want, so the t-test has been imported. So now let's generate a simulated data. So we'll use this one, the same amount of data, new method scores. So here, in spite of that, we will use a scores. This is the previous example. So new method, new underscore method underscore scores. So np dot random dot, so I'm gonna go for the different method here. So I'm gonna go for the normal. So LOC is equals to 85 and scale is equals to 10 and size is equals to 100. So the second one, the data set or sample with the traditional method scores. So np random normal, random, and then normal LOC. Let me go for the, let me copy this exactly. So LOC is equals to 80, scale 8, and size is 100. So now let's conduct a 2 sample t-test. So t statistic and p value, and let me change this to t stat. That's the t statistic value, t stat. Then we got the p value, p underscore val. Then t test underscore this of, I have to mention both the variables. So we have to compare both. So that's the reason I have to put both. So one is new method scores. Then after that we have a trade method scores. Done. So now it's time to print the respective results and then just do the significance test. So let's print the results. So print t statistic and other one, print so now let's print the results of the hypothesis testing. As usual, our alpha, let's decide the alpha first. So let's set significance level, that's alpha is equal to 0.5. So now let's print the results. Let's check for statistical significance. If p value is less than alpha, then if it is less than alpha, then the redesign, then let me write down this. The observed difference in mean test scores is statistically significant, statistically significant, and reject the null hypothesis. And similarly on the other side, uh, which would be if this the observed difference in the observed difference, let me copy this here. So the observed difference in mean test score is not statistically significant. So we reject, we fail to reject, or we conform. We conform. Either this is best way of telling fail to reject, or you can say conform the null hypothesis. And this is what the response is. You got the p-value of lesser, that's 0.00, and the t statistic is 3.94, and then corresponding p-value is this. So the observed difference, obviously p-value is lesser than the alpha, so the observed difference in mean test score is statistically significant, and we reject the null hypothesis. And this is what the example where we used statistical significance, p-value, t statistic, and significance level, type 1 error and type 2 error.